Hello, welcome to episode 10 of the Quest for AI. In the last video I showed you this function of functions which makes my program much more efficient, and I'm going to show you in this episode some of the updates I've made. So one version I worked on was one where I added a new characteristic of the program where instead of just being able to reset a single step of the investigation, you can reset the whole program. I'll show you what I had before. Your only option before was if you've told the bot what your preferences are as to how it should go about solving the crime, you can save these preferences and attempt a step again by typing reset after one step. But the problem is you can only reset that step. You can't reset the entire program with your saved preferences. You'd have to shut down the program, you have to stop it running and then try again. But when you open up the program again, it won't be saved. So you can't keep refreshing the program with your saved preferences, but you can now, because as well as being able to reset the step, you can reset the whole program. And this isn't just here. This is trying to find. Never mind. But yeah, basically that's what I've added. I'll probably start attaching like a document to these videos, or trying to find some web page where I can post the code, because I can't be bothered going through the whole code, and honestly it just takes too long. So I'm just going to zoom in on what I've changed, then add files in the description maybe, or in the comments. Yeah, I'm not going to run that because that's pretty self-explanatory, but my latest version is quite different. Now I've actually added different scales of positive reinforcement and negative reinforcement, whereas before the only inputs you could give to the bot were yes or no in terms of whether you wanted it to do a certain thing. But now you can add exclamation marks, so you can basically shout at it and that will change the preferences more severely. So here's how it used to work. So it used to be, if self-approval is no, then the weightings will go down by 25 and another one will go up by 25. So this represents a specific choice. This represents another. I forgot which one this is specifically, but this basically represents how likely it is to choose a specific course of action. And by saying no, you are reducing the chance that next time when you refresh, the bot will cause this choice of action. Been through this before 1,000 times. But how I've made this efficient in doing the same thing basically is I've treated the string like a list, which you can do sometimes in Python, by putting not self-approval A but self-approval A0. So that represents the first element in the string self-approval A. If that element is n, I'll tell you why that is in a minute, then the same thing happens. But if also, as well as the first element being n, the last element, the third element, is an exclamation mark, then it changes more drastically, so that the one that you don't want to happen is put down to 0, the one that you do want to happen is put up to 100, so you've got the respective minimum and maximum. So basically you're guaranteeing what you've said to it will be took on board by adding that exclamation mark, which obviously represents you shouting at it. Now the reason I needed to do all this business about dealing with the first element and the third element instead of just saying if self-approval A equals no exclamation mark is because I want to make it as efficient as possible. So instead of having if self-approval A equals no and then another statement saying if self-approval A equals no exclamation mark, I've sort of done it in one. So the first element could be n, so that means that it could either be no or no exclamation mark. So you're not really painting yourself into a corner if you say that. So all it knows, if this is true, is that the first letter is N, and then what we've got here is, so if the last letter or character is exclamation mark, then it's put up to the maximum, put down to the minimum. And then if that isn't true, as long as your user hasn't just typed it wrong, the only other possible alternative is that they've typed no with no exclamation mark. So that just does the regular. It just does the default weighting change in that case. So yeah, that's why I did that instead of just saying if equals no exclamation mark, because it's much more efficient. Yeah, that's all the changes I've made. I'll run this actually. So focusing. Say. So just to demonstrate, I'll say yes exclamation mark. So now next time, if I loop that around again, that's guaranteed to go for gathering evidence first. That's just a more firm way of me saying yes to the bot. Then I'll say carry with this crime. So the bot's gathered evidence, and it's deciding whether to arrest the man wearing a balaclava, pretty shifty guy, or the woman who seems to be quite not suspicious. And I'm training my bot to be an idiot actually, so I'll say no. So I'll say yes actually. It's the regular yes. And then obviously next time it's more likely to pick the woman again. So I'll say reset step on this actually to redo this step. Yeah, so it's looped around just that step. It hasn't restarted the whole program, it's just restarted that step. This time I'll say no, exclamation mark. And I'll undo that, what I've already done. So if I say again, reset step. Now, because I've guaranteed that it will go to the other option, now it's saying, should I arrest the man wearing a balaclava? And just to end it, I'll say yes. Okay, so I think that was pretty comprehensive, and so yeah, that's what I've changed so far. See you next episode. Thank you.